In this tutorial, we'll be looking at projecting and including sketch geometry. And after completing this tutorial, you'll be able to create sketch projections onto a surface and also create sketches including 3D geometry. As well as projecting and intersecting, we can also include existing 3D geometry into our sketches. Including 3D geometry essentially creates 3D curves from any referenced 3D geometry. Continuing from our previous tutorial, you'll need to have open the file called projecting, which you can download from the dataset available with this course. With the file open in front of you, in the browser, toggle off the visibility for the projected intersection that we created earlier. And then in the toolbar, click to create a new sketch. It doesn't matter which plane we create the new sketch on. I'm going to select the XZ plane, the ground plane. And from the sketch menu, select Project Include, then click Include 3D Geometry. With the tool activated, to include 3D geometry, we just need to select the sketch objects that we wish to include. We can include points, edges, and entire faces. Let's select and include all the faces of our model. With all the faces selected, let's toggle off the visibility of our component in the browser. Turning off the visibility of the component allows us to see all the 3D geometry that we've included into our sketch. With the 3D geometry now included in our sketch, we can toggle back on the visibility of the component in the browser, toggle off the visibility of the 3D geometry sketch, then click Stop Sketch. Now we'll take a look at our last Project Include, which will allow us to project onto a surface or the face of a 3D object such as a body. In order to demonstrate how to project a sketch onto a surface or the face of a body, I'm going to create a sketch on a new offset plane. In the toolbar, click Construct, Offset Plane. Let's toggle on the visibility of the origin for a moment and select the XY plane for our offset. Offset the plane 60mm. Click OK to close the dialog, and now we'll quickly create a new sketch on the offset plane. In the toolbar, click Create Sketch, then select the offset plane. Hit the C key on the keyboard to activate Center Diameter Circle, then create a circle with a diameter of 8mm. From the toolbar, click Sketch, Rectangular Pattern. Create 9 occurrences by using the manipulation arrows to drag the occurrences horizontally and vertically. Click OK to close the dialog. And then in the View cube, click Home in order to get a clear view of the new sketch and the surface onto which we'll project the sketch. So let's click Stop Sketch and now project the sketch onto the surface of the cube. In the toolbar, click Sketch, Project Include, Project to Surface. So we need to select a plane or a surface to create the sketch. We'll select the face of the cube, and because we're projecting to surface, we now need to select the face that we wish to project onto. Again, we'll select this face of the cube. Now we can select the curves or the sketch that we wish to project onto the face of the cube. And as you can see, as I select my sketches, they're being projected onto the surface. We have a choice of project type. We can project according to the closest point or along a vector. In this case, closest point works very well, so we'll leave it on closest point, then click OK to complete the projection. And now, if I turn off the components, we can see that we've successfully projected our patterned circle sketch onto the face of our component. All the projections and inclusions that we've made are associative, and if we edit earlier in the timeline, for example, all the projections and inclusions and all the geometry from the projections and inclusions will update according to those edits. If I go to the timeline and edit the size of the cube that I created, I'll use the manipulators to change the size of the cube, then click OK to confirm the edits. If we temporarily turn off the visibility of the component in the browser and toggle on the visibility of some of our projections, so for example, here's the regular project, we can see here that the size of the cube change is reflected in this projection, is also reflected in the intersect projection, and finally, our 3D geometry has also updated according to the new size change that I just made to the cube.